رب اشرح لي صدري اے میرے رب میرے لیے میرا سینہ کشادہ فرما دے او مائی لارڈ open for me my chest ويسر لي امري اور میرا کام آسان کر دے and easy my task for me واحلل عقدة من لساني يفقهوا قولي اور میری زبان کی گرہ کھول دے تاکہ وہ میری بات سمجھ سکے and let loose.
Okay. Bismillahirrahmanirrahim. So today our topic is the overlay design of highway pavement. This is Professor Adnan Kadir. Now, what is an overlay? Overlay is an extra layer of a pavement that is laid either on a disintegrated surface to improve the structural efficiency of the pavement, or it can be a 2-inch layer normally to, to rejuvenate the pavement surface in terms of its riding quality and improve skid resistance. Uh, as we, there are two types of rigid overlays. One is a rigid overlay, the other is a flexible overlay. We can further, a rigid overlay obviously is based of an asphalt or cement concrete that is based, that can be overlaid either on a cement concrete road or an asphalt concrete road, while flexible overlay means a 2-inch surface, asphalt surface, that is to be laid either on an existing asphalt surface or a cement concrete surface, or we can call this as a rigid pavement. So we can classify the overlays uh, into that into 4 categories: an asphalt overlay or an asphalt pavement, an asphalt overlay on cement concrete pavement, cement concrete overlay on asphalt pavement, and cement concrete overlays on cement concrete pavements. What are the basics of an overlay design? We can categorize as the measurement and estimation. This is the first step. The design life, the traffic, and the design of the overlay itself. When I mean the measurement and estimation, I mean the structure or non-structure evaluation of the pavement. What we do normally is to find out the condition of the pavement non-structurally. What I mean is just doing the pavement condition index survey. And when I mean pavement condition index survey, I mean calculate, observing the various type of distresses on pavement, like potholes, like rutting, like ravening, like reflection cracking, like alligator cracking, to name few, and following the procedure to estimate the pavement condition index. Normally, if the value of pavement condition index is below 30, it means you require an overlay. So this is one way. The other way is the structural evaluation of an existing pavement, in what we do some testing. One of the testing is the Benkelman beam testing, in which we measure the deflection. The other form is the falling weight deflectometer, in which we measure deflection. Again, all of these are non-destructive testing. Once you do that, and once you know the evaluated values, we can estimate and we can actually further know what should be the design of overlay uh, to rejuvenate the pavement. The design life can be estimated in terms of what we call the remaining service life of pavement. For instance, initially, if the pavement has been constructed for say 20 years, and from the estimation of our test, we can find that the remaining service life is 4 years. So we can design the overlay for 4 years. In any pavement design, be a new construction pavement design or an old design, we need to estimate traffic. And again, this method we will explain, we will calculate equivalent single axle load of 18 kips. So, though uh, other ways of estimated traffic has always has been come along, like knowing the spectrum of the traffic as explained in H2 Design 2002. But we, in this lecture, we'll talk about only estimating the traffic in the easels. And once we do it, we design this overlay by adopting some standard procedures, usually in an Asphalt Institute procedure that will be explained in the next slides. So if you want to design an asphalt overlay, there are two methods. One is an effective thickness method. The other is a deflection-based design. In effective thickness method, what we do, we estimate the, actually what not, we do not estimate the thickness. Actually what we do, we know the actual thickness of the pavement of various, having various layers, and then what we do is to estimate the remaining strength of the pavement by adopting some standard factors using as guided by Asphalt Institute, and we know how much pavement thickness can be utilized for a new pavement. So this is an effective thickness method. And talking about its approach, its merits and demerits, the merit is very simple, it's less complex, easy, adaptable, design is easy, but at the same time, the question arises, the factors, whatever factor you have used, is it okay? Is it correctly estimated? Because it depends on the judgment of a person designing a pavement. So what may happen that either will design, let me say, wrong pavement, or what we call not very cost effective pavement, or or we design an under strength pavement. So both can, how we can do, sometimes you estimate that the effective thickness is good. So conversely, you will find less overlay thickness. Or on the other hand, if you do not estimate or you estimate the effective thickness very low, you end up with an extra overlay that may not be needed. To cater for that, the other approach of overlay design is the deflection based design. Now, what we do, we use some standard equipment having also been standardized as a standard test, like Begelman beam and falling wave deflectometer. As the name suggests, the deflections of a surface is being measured, and then these deflections are being manipulated to calculate the overlay thickness of the pavement. As compared to effective thickness method, they are more complex, but their design is reliable and economical because they are based on the actual measurement and it's not based on an observation of an individual. But at the same time, the equipment cost is high, as well as it needs expertise, special expertise of the people to design that overlay. In this lecture, we'll talk about both of these methods in slight detail. Now, how you do before applying the first approach, that is what we call the component analysis. We first know the traffic. We then determine the subgrade support. We analyze the existing pavement structure. We determine the new pavement thickness, and then we find the required overlay thickness. For doing traffic analysis, we adopt the same method as we do in calculating equal single axle load of 18 kips using H2 1993 methods protocols. And that is to be done all the time. But there are also guidelines available. If you don't have a real data, then you can take one of these values depending upon the location, depending upon the functional classification of the highway you are designing or overlay for. For instance, if you're designing parking lot, like residential streets and farm roads, it can be 5,000 easels. The residential streets, the rural farms and residential roads, we can start with 10,000. We go for urban and rural minor collectors, it can be 100,000. Urban minor arterials, light interstate streets, rural major collectors, and rural minor arterials highway, it's 1 million. Urban freeways, municipal arterials, more than 3 million. And some provincial highways and industry roads having more than 10 million. But we are living in an area where traffics are always more, the loadings are not being controlled. So, as an expert in this subject, I would advise you to take the actual easels or calculate the easel that is to be required rather than following these three. This estimation will be good for just to make an initial budget, but it's if you're going for the final design, just estimate the traffic yourself instead of adopting this guideline. Now, as for subgrade support, we always use the CBR, resident modulus, or if you are doing this for a rigid pavement, you can take modulus of subgrade action. This asphalt institute method, they take the input of soil subgrade in terms of resident modulus. So whatever you have a CBR, you find this resident, you correlate this as you can see, if you have a CBR value, you can use this Ashto equation 2002 as MR is 2555, CBR raised to power 0.64. Again, it is always recommended that you conduct the standard resin modulus test in the laboratory and to come up with this value of the soil. But as we all know, that this resin modulus test facilities are not available in most of the places due to its higher cost of purchase, and not only the higher cost but the expertise. So normally what we do is we perform CBR and use the relation to calculate MR, and this is a standard method. Just an idea, if your soil is soft plastic, CBR will be around 3. If you have a silty sand, CBR will be around 8. And if you have a sand gravel, then your CBR will be around 17. Maybe 17, I think it's too much, but since it has been uh, taken from a standard book, though I will recommend not to take more CBR more than 12 for design purpose, and accordingly, if the you can say it's poor is CBR 3, fair is 8, and for good CBR is 70. This is how to determine the subgrade support. Now, the third method in which what you do, you use these conversion factors to uh, know the effective thickness of an existing pavement. So, if you have improved soil subgrade, having predominantly granular material or lime modified, your conversion factor is 0. So, for us, you can always say that you don't give any weightage to an improved subgrade. It's always 0. Then, if you have the regular subbase or base having a CBR not less than 20, then you can give this a weightage value of 10 to 30%. And you can include that cement modified subbases and base as well. Now, if you have a cement or lime fly ash basis with pattern cracking, or cutback asphalt surfaces, or PCC pavement broken into pieces, you can give an effectiveness as high as 50%. And if you have a hot mix asphalt surface and that have an extensive cracking, you can find this weightage as between 50 to 70%. And for an uncracked HMA PCC, you can give them 100% weightages. Again, as a designer, I would rather go the, the middle values or average values of this table. For instance, For an uncorrect paved HMA, I will go for 0.95 instead of taking 0.901. This is just again the guidelines. Now, what you do once you know from the traffic and resonant modulus, once you know the full depth thickness, you subtract it with existing equivalent thickness to find the thickness of a new overlay. So let us see how, let us solve an example to find the overlay thickness to explain how this method worked. So you have been given traffic 30 million per lane per direction, equivalent single axle load of 18 pounds. The resonant modulus is 12,000 psi. The detail of pavement section is asphalt concrete 6 inches. It includes bearing courses and base. The crushed stone base is 8-inch, granular subbase 10-inch. Here we have not been given subgrade value because we understand from the previous slide that we don't need the since our weightage factor is 0, so we don't require and we're not interested in knowing any thickness other than that. You can say that overall pavement in poor conditions with well-defined cracks. This is for an HMA. What you do, the first two steps had already been done because you know the traffic, you know the resonant modulus. Now, what you do, we find the effective pavement thickness. So the first one is 6 inches. So we will find 0.5 as explained 2 slides ago, where you find, you know, the conversion factor 0.5 inches. So the effective thickness, you have to multiply 6 by 0.5, it becomes 3 inches. So base as for asphalt surface, that was actually 6 inches. Now effectively it is 3 inches as per this methodology. So for 8-inch base, it is 1.6. Again, 8 multiplied by 0.2 is 1.6. And then for 10-inch sub base, it's 0.2. And we take, if we multiply 0.2 by 10, it's 2. So the effective thickness of the pavement is 6.6 inches as compared to 24 inches pavement that was laid. So it means by this method, you are, taking 25, around 25 to 30% of thickness as an effective thickness. So what we can say, as I was discussing in the demerits, that sometimes your overlay design may not be very economical because we have taken some fact, we have some visual observations. So this is a risk, but at the same time, you may have an overestimated design, but that may also be good uh, as to consider the safety factor, but it will not be economical. Now, for this, once you know the resonant modulus initials, just what you draw a graph of 12,000, make a perpendicular from 12,000. This is a subgrade, and you know there's 3 million easels, 30 million easels. So when you draw a graph and you find this intersection, the estimated thickness is around 14.5 inches. So this is a new thickness required. So once you know the need requirement of knee thickness according to the easels and resonant modulus value, what you do is just subtract the effective thickness from the knee thickness and you'll find that overlay is 9.4 inches. Now, this is a 9.4 inches. It means you can say that it will have a 2 inches an asphalt bearing force and 7.54 inches of an asphaltic base force. So this is how you design an overlay using component analysis technique, and this also ends our first part of this overlay design. In the next part, we'll talk about the deflection approach to design the pavement. Till then, Allah, please and take care.